go to Abuela's house. Who do we call when we don't know where to go?
The map! The map!
The map, that's right. Can you say map?
Map!
If there's a place you gotta go, I'm the one you need to know. I'm the map.
Dora and Boots need to find the way to Grandma's house. The path to Grandma's house is both differentiable and continuous.
Okay, Dora, look at these graphs. You see that they're both continuous, right? Because I can take my pen and trace the whole line without picking it up, right?
See.
But they're also differentiable because at every point on both of these, I can determine what the slope is, right?
See.
So that's what you have to have. In order for a line to be differentiable, it has to be continuous. Any line that's not continuous can't be differentiable. Any line that is continuous, it's only differentiable if you can find the slope at every point. Now, there are a couple of special lines that are continuous but are not differentiable. Do you want to see them?
See.
Okay, let's start with this one. This one's called a corner. Now, if you were going to look at this, which spot do you think is not differentiable?
I think it's right there, Abuela.
Yeah, that's right. The slope of these points is over here, and the slope of these points is that way. But that point, we don't really know what its slope is. So it's not differentiable even though it's continuous. Okay, what about this one?
I think it's there.
Yeah, good job, Dora. You're right. Because over here, the slope is this way, and over here, the slope is that way. But at that point, we don't really know what the slope is. Okay, what about this one, Dora?
That's a little tricky. Is it right there?
Yeah, that's right. This is a vertical tangent. That slope is undefined, kind of right at that point in the middle. Undefined means no one knows what it is. Anyways, so this one is a discontinuity. What do you think about this one?
It's almost as if there's a hole that starts again up there.
Yeah, even though every point along this line is accounted for, there's a gap here, which means that we can't figure out the slope at that point because it's kind of in two places at once. Does that make sense?
Yes.
Okay, so now that we've looked at these graphs, do you remember what it means to be continuous and to be differentiable?
Yes, Abuela. It means to continuous means that you can do your pin all throughout the line. And then if it's differentiable, I can feel the slope of each point on the line.
Yeah, good job, Dora.
Is this path differentiable? That's right, it's not. Is this path differentiable? Right again, it's not. But this path is both differentiable and continuous. Tell Dora that the path to Grandma's house goes over the river through the woods. Let's check the map again to see which way we're going. Oh no, we don't have graphs, we only have equations.
Don't worry, Dora. Maybe we can graph them.
You're right, Boots. I have graph paper right here.
So these were the 4 equations we were given. For each equation, we made a data table. And then we graphed each equation. This one is not differentiable because it's a cusp. This one is not differentiable because it has a corner. This one is also not differentiable because it has a corner as well. However, 4 is differentiable because you can find the slope at any given point. So that's the path we take.
Oh no, here comes Swiper. Say it with me.
Swiper, no swiping.
Oh no, we were too late.
It's okay, I remember which path to take.
Oh no, we don't know where to go. All the map gave us were 3 equations. The one that's both continuous and differentiable will get us to Abuela's house, but I don't know which one is.
Dora, I know I'm Swiper and I'm supposed to ruin your life, but can you please forgive me and trust me to help you this time?
Of course, Swiper, I forgive you.
All right, so to figure out if a piecewise function is continuous at a point, we're going to set the functions equal to each other. So we have x squared plus 2 which equals x squared, x plus 2. And then we're going to plug in 1 to each point because that's where the two piecewise functions meet. So we have 1 plus 2, which equals 1 plus 2, and 3 does equal 3. So yes, this piecewise function is continuous at this point. Now let's see if it's differentiable at this point. We're going to take the derivative of x squared plus 2, which is going to be 2x. We're going to set that equal to the derivative of x plus 2, which will be 1. Plug in the 1. 2 does equal 1, but it does not. So no, this one is not differentiable. Sad. All right, now let's see if these two functions are continuous. So what do we do first? Good answer. 1 minus x equals 1 minus x plus 2x squared. Plug in our 0. 1 minus 0 equals 1 minus 0 plus 0. 1 does equal 1. So yes, this graph is continuous. Yay. All right, now let's see if it's differentiable. The derivative of 1 minus x is going to be negative 1. Set that equal to negative 1 plus 4x. All right, let's plug in our 0. Negative 1 equals negative 1 plus 0. Negative 1 does equal negative 1. Yes, this is also differentiable. Woohoo! All right, our last one. Negative 1 equals 1. We have nothing to plug in, and this does not equal each other, so no, this is not continuous. And if something is not continuous, what does that mean? Good answer. It means it's not differentiable as well.
Thanks, Swiper. Now we know that this is the way to get to Grandma's house.
Good job.
Abuela, I made it!
Oh, Dora! Oh, I'm so proud of you. And you remembered all the things that I taught you?
See.
Oh, good job. Good job.
Thank you for your help.
You're welcome.